Good morning, guys. Today I have taken the last lecture on the unit number 6. Okay, this is the last part on the unit number 6. Last lecture we have seen the combined bending and direct stresses. Today we will going on the torsion combined with axial load. In that torsion, there is a direct stress and torsional stress are combined on given shaft. Okay, before going on that, see, we require the some formulas, or we know the some formulas. We have seen the unit number 6 as well as unit number 3 and unit number 5. What is the torsional stress? How to act this torsional stress? See, here is how to calculate the direct stress first. Direct stress is nothing but the force upon cross-sectional area. Okay. Then how to calculate or how to find out the torque act on the shaft. Last lecture also we have seen this one, how to the torque act on the shaft. With the help of power formula, you can calculate the value of torque. If you know the power, then easily you can calculate the torque. 2 pi t divided by 60. And important is there related to the torsion. Okay, we have seen the unit number 4. There is a torsion is given. Okay, separate unit is given. What is the torsional formula? We know that. Okay, this shear stress due to the twist, okay, or angle. We know the torsional formula. This T by J is equal to G theta by L is equal to tau by R. What is the T? Torque act on the shaft. What is the J? J is nothing but the polar moment of inertia. Then what is the G? Modulus of rigidity. Theta is the twist angle. L is the length of the shaft. Tau is the shear stress and R is the radius of curvature. All the details we have seen in the torsion unit. You should remember the formula. Here is a combination of direct stress and another is a torsional stress. Okay, that's why we require the torque, the shear stress. Then how to calculate the maximum stress? We have seen how to calculate the maximum stress. Root of sigma divided by 2 bracket square plus tau square. Remember this formula. With the help of this formula, you can calculate the maximum stress. Then how to calculate the principal stresses? We know the sigma n1 and sigma n2. But when you find out the principal stresses in unidirectional or bidirectional, then remember that this is the generalized formula. Sigma n is equal to sigma divided by 2 plus or minus root of sigma by 2 bracket square plus tau square. Okay, only addition is here sigma by 2. Here you have to use the, when you find out the sigma n1, sigma by 2 plus is there, and when you find out the sigma n2, then sigma 2 minus is there. Okay, this formula we want to use. What is the application of this? I have taken one application of the propeller shaft. One propeller shaft is given having the length 0.5 meter, or we can say the 50 centimeter. Okay, then there is a torque is act in the anti-clockwise direction on that propeller throat. The force is act. There is a compressive force is act 10 kilonewton. 10 kilonewton. Force is act 10 kilonewton. I have converted into the 10 in Newton. 10 into kilo means what? 10 raised to 3 is there. This compressive force is act. The speed of the propeller shaft is given, n is equal to 300 rpm, and the power is required is 30,000 kilowatt. I have converted into the watt. 3000 into 10 raised to 3 watt. Okay, and length is given, L is equal to 0.5 meter is there. The diameter of that shaft is given 250 mm and weight is given 40 kilonewton. 40 kilonewton. These things are given. We want to find out the principal stresses. Then how to calculate the principal stresses? You know the formula is sigma n is equal to sigma divided by 2 plus or minus sigma by 2 bracket square plus tau square. Here we want to calculate the value of which value? Direct stress, as well as we want to calculate the shear stress. Also then we will get the principal stresses. Then which value will get the principal stresses? We will see the one by one. What is the value of that? Also we will require the bending stress. Bending stress sigma is there. Okay, we want to calculate the bending stress. Okay, this value we want to calculate with the help of some calculations. Okay, see first what we want to calculate. First we know the value of that sigma n, sigma divided by 2 plus or minus sigma by 2 square plus tau square. How to calculate that stress? Stress is nothing but it is the summation of the direct stress and bending stress. We want to calculate this value, and once we are getting this value, then you have to put in this equation. Okay, then we will start. First we want to calculate the area. Okay, we don't know the area of that propeller shaft. What is this circular shaft is given pi by 4 into d square. What is the value of d? They have given 250 square is there. Okay, then you will get this value when you calculate. Then you will get 49087.4. What is the unit of area? mm square. Once you have calculated the area, we require the another value, the moment of inertia about the x axis. What is the formula for the circular? Pi by 64 into d raised to 4. We have seen already. Pi by 4 into 64. Pi by 64 into d raised to 4. 250 raised to 4 is there. If you have calculated this, then you will get the 191.75 into 10 raised to 6. What is the unit of moment of inertia? mm raised to 4. What is the moment of inertia for the circular bar? Pi by 64 into d raised to 4. If you have given the rectangular bar, then what is the value of pi? bd cube divided by 12 about the x axis. Then next is we want to calculate the polar sectional modulus. Polar sectional modulus is nothing but the ratio of polar moment of inertia to the radius of curvature. Then if you have calculated this, then you will get the pi by 16 into d cube. Pi by 16 into d cube. Again we know the d value. Pi by 16 into d is 250 cube. Then we'll get 3.07 into 10 raised to 6 mm raised to cube is there. Okay, mm cube is there. Remember the units also. Here I have written direct formula, polar moment of inertia divided by radius of curvature. Already we have seen, that's why I have written the directly this formula. I have calculate all geometrical part. Okay, area, moment of inertia and polar sectional modulus. Then second, we want to calculate the torque applied on that shaft. How to calculate the torque applied on that shaft? This power is given. Okay, then again RPM is given. Okay, speed is given of the shaft. Then easily we can calculate the torque value. Then which formula will use? Power is equal to 2 pi mt divided by 60 is there. Therefore, power I have right here 30,000. 3,000 into 10 raised to 3. What is the is equal to 2 pi n. What is the value of n? 300 rpm into t divided by 60 is there. Divided by 60 is there. Okay. This value I have written. Then you will get the t is equal to if you have calculated, then you will get the 95.95493 Newton meter. If you want to convert it to the Newton mm, then how to convert? 95.493 into 10 raised to 6 Newton mm. Okay, Newton mm. Because all dimensions we have find out in mm, that's why I have converted into this value Newton meter to Newton mm. Okay, you know 1 meter is equal to 1000 mm is there. Once you have calculated that T value, then next we want to calculate due to that propeller float, there is a movement will act. Okay, then we want to calculate that movement. How to calculate movement? W into L. W into L is there. Okay, that weight is at given 40 kilonewton. I have right here as it is 40. Then meter 0.5 is there. Okay, then you will get the 20 kilonewton meter. What is the movement? Movement is nothing but the force into distance. What is the unit of the force? Kilonewton is there. Okay, and what is the unit of the distance? Meter is there. That's why you will get the 20 kilonewton meter. You can convert it to the Newton mm also. How to convert again? What is the kilo? 10 raised to 3. Again here meter to mm means 10 raised to 3. You will get the 10 raised to 6 Newton mm. Okay, this is the value of movement. Okay, then next we want to calculate the direct stress. Direct stress is denoted by the sigma d. You know that the force upon cross-sectional area. Okay, how much force is that? This is the compressive force. 10 kilonewton is there. Force is at 10 kilonewton. Okay, I will convert it to the Newton. 10 into 10 raised to 3. 10 into the 10 raised to 3 means 10,000 Newton. What is the area? We have calculated the area. 49087.4 is there. Okay. Once you have put this to value, then easily you can calculate this value 0.20 Newton per mm square. Okay, what is the value? Unit of the stress? Newton per mm square. Because force unit Newton and area unit is mm square. Then you will get the Newton per mm square. Once you have calculated this, then see the next one. Next, what we want to calculate? We require the value of sigma b. Before going on that sigma b, we require the value of tau. How to calculate the tau? You know the torsional formula. T by J is equal to tau by R. T by J is equal to tau by R. Then again here I will making some simplification. T is equal to, I will write J by R into tau is there. What is the J by R again? Polar sectional modulus ZP. Already we have calculated the value of ZP. Then you will get the tau is equal to directly I will put tau is equal to this J by R, nothing but ZP. Tau is equal to T by ZP is there. Already we have seen in the torsion unit ZP. Then put the value of T and ZP. Both value we know that. What is the value of T? 95.493 into 10 raised to 6. Divided by what is the value of ZP? What is the value of ZP? Here is a 3.07 into 10 raised to 6. 10 raised to 6 get cancelled. You will get the tau is equal to, once you have calculated this, you will get the 30.1 Newton per mm square. This is the value of shear stress. Then next, what we want to calculate? I will erase this. See, next we want to calculate the bending stress. Okay, due to the movement here we will get the bending in the shaft. Okay, we know the bending formula. Yes, what is the bending formula? Sigma B is the bending stress is equal equal to m by I into y. Okay, or we can say the y bar. Sigma b is equal to m by I into y bar. Okay, what is the value of m? We have calculated 20 into 10 raised to 6. What is the value of I? Moment of inertia. We have calculated that moment of inertia 191.75 into 10 raised to 6. This get cancelled, 10 raised to 6 into y bar. How to calculate the y bar? Y bar is nothing but the distance from the centroidal to the top portion of the shaft. Okay, means what is this diameter is given 250. 250 divided by 2 is there. Okay, if we have calculated this sigma b, then you will get this plus or minus 30.04 Newton per mm square. We don't know the exactly there is a tensile or compressive nature of that bending. That's why I have written plus or minus this bending stress. Then we want to calculate after that resultant stress. Okay, we calculate only the resultant stress in x direction. Is resultant stress in x direction. Okay, resultant stress in x direction. When you calculate the resultant stress in x direction, this sigma x is equal to sigma d plus or minus sigma b is there. Okay, what is the value of sigma d? We have already calculated that sigma d is negative because of compressive force, minus 0.204 na? Yes, Newton per mm square. This is the sigma d value. I will write here minus. Once I will take the we don't know the nature of the bending. This is compressive or tensile. Okay, that's why I have taken here negative. Okay, we will consider first compressive nature of the bending. That's why you will get the 13.04 Newton per mm square, and you will get this value minus 13.2 is there, 244 is there Newton per mm square. Okay, this is the resultant stress in x direction. Also, you will get the another value for the resultant stress in x direction. I will write here sigma d plus is there. Here I have written the minus. Okay, minus, and here is a plus sigma b. Again minus 0.204 plus 13.04. If you have calculated this, then you will get the 12.84 Newton per mm square. This is the tensile nature and this is the compressive nature. Okay, all of you getting how to solve this type of the numerical? You have calculated the resultant stress in x direction. Once you have calculated, we will check that. Once you have calculated, then see the next what to do. You can calculate this also graphical method. You can calculate this also in graphical method. Okay, today we'll stop here. I will check this both answers are correct. Once you have got the sigma x and sigma tau, then you have to put the value. Okay, next one, once you have calculated that, then we will calculate the sigma n value. How to calculate the sigma n? Sigma n is nothing but the sigma n is equal to sigma divided by 2 plus or minus root of sigma divided by 2 bracket square plus tau square. Okay, what is the value of sigma x? I will take this first second value. You have to choose this two value. Okay, how to choose this value? First I will check this sigma x. Okay, resultant stress minus 13.244 divided by 2 plus or minus root of again 13.244 divided by 2 square what is the tau square? We have calculated tau 31.1 is there. I will check that value. 31.1 is there. Yes, this value is correct. Then you will get minus 6.62 plus or minus this value, you will get 31.8 is there. Okay, then how to calculate that? Sigma n1, you will get the 25.18, sigma n1 25.18 Newton per mm square, and sigma n2, here you have to take the other minus, then you will get the minus 38.42 Newton per mm square. In this way, you can calculate the value of normal stresses, okay, or we can say the principal stresses at the bottom and principal stresses at the top. Only you have to put this value, okay. When you calculate for the principal stresses at the bottom, I have choose this compressive nature. If you have calculate the principal stresses at the top, then you have to choose this value 12.84 and do the same calculation. Today we will stop here. Next lecture we will take the Zoom meeting. Okay. If you have any query, then you can ask me. I will repeat that.